So it's really time to do something. The economic situation is very difficult and IT can make such a massive difference.
Hundreds of thousands of people benefiting from those programs.
To subsequently secure jobs.
Link people very directly to jobs in Europe.
21st century skills.
Bridge the gap.
Massive open online courses.
Between 300,000 and 800,000 vacancy on the ICT sector.
We are very concerned, of course, about the widening skill gap in Europe and especially the rise of youth unemployment.
In a time when unemployment is reaching all-time highs in many member states in the European Union, so we've pledged to develop a new certification program. This is a new ECDL. So it allows the creation of profiles that match individual and organizational needs, and using this flexibility, both people and employers can develop digital competence that delivers productivity directly.
So our pledge is to develop education curriculum addressing smart grid networking skills and enabling the usage of the Cisco Networking Academy program to train smart grid professionals. Our contribution is to help smart grid professionals acquire the 21st century skills necessary to develop the grid infrastructure of the future.
CIPES and its member societies, that are the national informatics societies and the professional bodies around Europe, recognise that there is a need to bridge the gap between the skills that ICT professionals have and the demand for those skills in the market. We will launch the CIPES e-competence benchmark. So this is an online interactive tool, and it is designed to help current and future ICT professionals identify the competences that they will need for their ICT roles.
We're pledging to create a pilot into the use of massive open online courses for teachers, and we'd like to train the teachers to better help their students into digital jobs. We want to see young people that are more motivated for ICT jobs, who leave school thinking about going into more IT-related subjects.
I'm here speaking on behalf of 6 leading company associations which are here. The pledge is about e-competence framework. E-competence framework is almost a standard, as we hope it will, because it became soon a standard, which enables to describe the competencies of ICT practitioner and ICT managers. We are speaking, according to the latest study, about between 300,000 and 800,000 vacancy on the ICT sector for the next 2 years.
We represent a very unique relationship between the private sector and the state. Okay? What we do is we arrange for people who are suffering from long-term unemployment to be put through an IT training program to subsequently secure jobs. Our pledge is to take our training model and bring it to other countries in Europe. The impact of our pledge, very specifically, is to train enough people to fill 12,000 jobs over the next 3 years.
It's really time to do something. The economic situation is very difficult and IT can make such a massive difference on creating jobs and innovation. So our pledge in essence is accelerating our skills initiatives, our HB Institute program, our LIFE program and social innovation program, to really make our skills and our competencies available to up to 1 million students and professionals.
We are very concerned, of course, about the widening skill gap in Europe and especially the rise of youth unemployment. Academic Cube is a unique platform because it combines e-learning and matchmaking. It's also unique because it combines content of multiple partners, and it provides a platform for unemployed students, for job agencies and also industry to really match skills with open positions.
So we've decided to extend our commitment to the Grand Coalition and pledge even more this year. It's a career fair which will take place at Campus Party in September 2013, which will offer recruitment training opportunities at the O2 Arena to more than 10,000 young people, and at which we invite companies to join us. We want to have also, if we can, more than 1,000 children educated in hacking and in coding. So these are really ambitious targets, and I think if we can partner with others, we can probably perceive in 2014 and 2015 to reach in the hundreds of thousands of people benefiting from those programs.
Imagine everything was linked. Let's say there was a traffic accident somewhere on the road. A built-in system in the cars could automatically alert the emergency services. With precise geolocation data, they can send an ambulance to the crash site. Furthermore, this new information would be passed on to a system that alerts me as I'm driving and suggests an alternative route to get to my destination.
Imagine we had an Internet of Things. Wouldn't that be more efficient?
The Simple Show explains graphene. This is graphene. Let's call him Mr. G. He is the first material that is two-dimensional. This gives him a unique set of properties. Since 1859, many scientists were looking for graphene using complex experiments. But the first crystals of graphene were discovered in 2004 using a very simple and effective method, namely ordinary Scotch tape. During Friday evening experiments in Manchester, scientists noticed small parts of graphene on the tape used to clean a graphite stone. The two scientists, Andrei Geim and Konstantin Novoselov, were awarded with the Nobel Prize in Physics 2010 for this simple but groundbreaking experiment. Thanks to the Scotch tape method, this area of science grew extremely quickly, and today hundreds of laboratories all over the world deal with different aspects of G research. What makes Mr. G a really super material is the combination of his unique properties. G is the first 2D crystal ever known to us, the thinnest object ever obtained, and also the lightest one. G is the world's strongest material, harder than diamond and about 300 times stronger than steel. G conducts electricity, much better than copper. G is a transparent material. G is bendable and can take any form you want. And this unique supermaterial gave birth to a new class of crystals that also are just 1 atom thin. And what's more fantastic is that these can be shuffled with each other to engineer new materials on demand to meet the special needs of different industries. All these factors moved graphene swiftly from the G Research Laboratory to the G Marketplace, driven by demand from industries where such supermaterials are required. Aerospace, automotive, electronics, energy storage, coatings and paints, communications, sensor, solar, oil, etc. Thanks to mass production methods intensively being developed, expect to meet Mr. G in person soon. Get more information at graphene-flagship.eu.
Imagine everything was linked. Let's say an elderly person forgot to take a pill prescribed by the doctor. This could trigger an alert warning a family member on their mobile phone. If that person is not available, it would make a call to a second family member. Now, if this person is also unavailable, it could then alert a local emergency centre, which would send someone to check things out.
Imagine we had an Internet of Things. Wouldn't that save a lot of lives?
A 100 billion neurons connected by 100,000 billion synapses. The human brain is the most complex machine we know of, and the most mysterious one. Brain diseases have become an immense burden in the Western world. In Europe, they cost more than heart diseases, cancer, and diabetes all put together. European researchers propose a radically new approach to study the human mind. Their idea is simple: to simulate a complete human brain in a supercomputer.
What we are proposing is to establish a radically new foundation to explore and understand the brain, its diseases, and to use that knowledge to build new computing technologies.
The researchers will systematically study neurons, the building blocks of the brain. They will collect and consolidate all the biological data produced by scientists around the world. They will integrate this knowledge into a massive simulation running on a supercomputer. The result will be the most accurate model of the human brain ever produced. The simulation of a complete human brain will require supercomputers that are 1,000 times more powerful than today. By understanding how cognition works, it will help to design radically new devices called neuromorphic computers. They will combine the power of microelectronics with the flexibility of human intelligence.
I'm really thrilled to help neuroscience to have a more coordinated effort, to understand the brain and to exploit the brain, to really use what's in the brain in computational principles and to derive new technologies.
The Human Brain Project brings together hundreds of scientists from leading European research institutions. It is one of the most ambitious neuroscience projects in the world.
By putting so many different people together and making such a big community, such a big project, we can do things we could never do with any other smaller scale project.
The Human Brain Project will put Europe at the forefront of neuroscience. It will deliver new strategies to fight brain diseases, and it will revolutionize electronics. But first of all, it will offer a revolutionary new tool to study the most mysterious phenomenon of the universe, the human brain.
Imagine everything was linked. Let's say a professor at the university is not feeling well and calls in sick. An automatic system at the school could send an alert to all the students that the class was cancelled. Furthermore, this information is passed on to a system that adapts my agenda. It calculates the new time to my next class 2 hours later, taking into account public transport timetables. It could also reset my alarm clock to wake me up a bit later, and it could adjust the central heating system and the coffee machine.
Imagine we had an Internet of Things. Wouldn't that be awesome?